Hello friends, welcome to learning STAAD Pro. And as you know, in the earthquake analysis, there are two methods, static analysis method और dynamic analysis method. So इस वीडियो में हम स्टैटिक एनालिसिस मेथड के बारे में डिस्कशन करेंगे और उसमें कौन सी फॉर्मूला होती है और कौन कौन से कोड यूज करके हम ये फॉर्मूला फाइंड आउट कर सकते हैं, वो सब के बारे में हम डिस्कशन करेंगे. So first of all, we will use static analysis method. So this is the method that we are going to right now discuss. So in the static analysis method, that is also called as a equivalent static analysis method. So static analysis method को equivalent static analysis method भी बोला जाता है. जैसे भी आपको पता है कि पिछले वीडियो में मैंने डिस्कस किया था, फिर भी मैं एक बार रिवाइंड करवा देता हूँ कि earthquake analysis, in that we are ready to find the horizontal forces. So the forces that are coming from the horizontal direction, that is positive x direction, negative x direction, positive z direction, negative z direction. So these are the four forces that we are going to be find out while the analysis of the earthquake as per IS 1893 Part 1 2016 revision, and horizontal forces are the predominant forces. So we are ready to find the forces in the two directions. One is the x direction and another one is the z direction. And as you know, force is a vector quantity. So force 1 is the vector quantity. Now, for the analysis of earthquake as per Indian Standard Codes, we are using IS 1893 Part 1 2016 revision. This code is used for criteria for earthquake resistance design of the structures. So in that we are going to use part 1, that is general provisions and building. So these are the codes that we are using. Now problem statement. So we will look at the problem statement first of all. So this one problem statement that first we are going to discuss, and then after we will start for the first method, that is static analysis method. So what we are going to do, we will cover this problem first of all. So our first story height is 4200, that is 4200 mm, and the rest of the floor's height is 3200 mm. Our building has the four span horizontally, 1, 2, 3, 4, and 3 spans vertically. Each and every span has a distance or spacing base of around 5000 mm. So this one is the plan of the building and this one is the elevation of the building. Now the design criteria is dead load, that is 12 kN per meter, that we have considered for all the floors. So 1, 2, 3, all the floors dead load is 12 kN per meter square, and live load, all the floors live load is 4 kN per meter square. 1, 2, 3, and at the top live load is 1.5 kN per meter square and dead load is 10 kilonewton per meter square. So this is the loading criteria that we are going to take, and this is the building type, that is office building type. Location is Shillong. Then after medium steep soil that we are using, and RC frame structure that we are going to use. So this is the problem statement that we are going to be discussed. Now, as you know, we are ready to find the lateral forces. Lateral forces, that is horizontal forces. So horizontal forces, that's this one is the plan, and this is my x direction positive, x direction negative, z direction positive, z direction negative. So sum of all these forces will be at, that is the total forces. So Fx and Fy. So this one is the total forces, that is Fx and Fz. Sorry, Fx and Fz. So these total forces, which will be called as a lateral force or base shear force. So we can also called as a base shear force. So base shear force that we are going to ready to calculate, that is base shear force. And in the base shear force, what we are going to do, that is we are going to calculate base shear, and in the base shear the value that we will comes out from the calculation that we will divide in each and every floor. उसका मतलब क्या है कि मान लो कि आपको एक वैल्यू मिली, so you know, let's say this one is the value x kilonewton is the base floors. So this base floors now divided in each and every floor. So this base floor now divided each and every floor. Let's say we have G plus 3. So all the G plus 3 stories, our base shear will be divided. How to divide the base shear, that I will discuss later on. Don't worry about that. We will perform each and every step by step, slowly. So let us we will see that the static analysis method. So in the static analysis method, these are the criteria that first we have to go through. So this method is an empirical method. So what it has been, empirical method means what? So in the empirical method, this is a calculation based method. This is not exact method. This method has been derived from the number of experiment has been performed. तो ये एक ऐसा मेथड है कि जिसमें बहुत सारे नंबर ऑफ एक्सपेरिमेंट रिसर्च ने परफॉर्म किया है और उसके बेसिस के ऊपर एक फॉर्मूला डिराइव की हुई है, उसको बोलते हैं एम्पिरिकल मेथड. दिस डज नॉट कंसीडर द क्विक मोशन. तो मोशन का जो इफेक्ट है वो यहाँ पर कंसीडर नहीं किया जाएगा. देन आफ्टर it does not also consider the effect of vibration. So vibration, motion यहाँ पर लिया नहीं जाएगा. Then it does not consider the effect of the time, and it will be also require the dynamic analysis to perform this method. So static analysis, this is the formula. This is the very most important formula for static analysis. VB equal to AH into W. So VB means what? VB means the base shear. Okay, so you can also write VB is the base shear or lateral force. You can also call it as a VB as a lateral force. So VB is the base shear or lateral force. Okay, AH is the design horizontal acceleration coefficient. So in short, you can remember AH is the coefficient and W is the seismic weight of the building. So while we are performing static analysis method, this is the formula that we are going to use. हम फॉर्मूला ये वाली फॉर्मूला यूज करेंगे, VB इक्वल टू AH इंटू W. उसमें AH फाइंड करेंगे, फिर W भी फाइंड करेंगे, राइट. अभी ये AH और W कैसे निकालते हैं उसके बारे में मैं डिटेल में डिस्कशन करूंगा. So VB is the AH into W, and if W is the weight of the building at the time of the earthquake. So let us say you are going to calculate the total weight of the W. So while earthquake will be come, मान लो कि earthquake यहाँ पर एक्ट कर रहा है, so this building will be try to rotate like this. So it will be try to rotate like this. So this building will be try to rotate like this and this. So like this way, your building is going to be rotate. Okay, so the orientation of the building has been now changed. So let's start. What is the resisting force? So ये जो ओरिएंटेशन उसका चेंज हो रहा है उसके पीछे उसका रेजिस्टेंस फोर्स क्या होना चाहिए. तो उसके पीछे हम बात डिस्कशन करेंगे. हम बात करेंगे कि हम जो W कैलकुलेट कर रहे हैं, W कैलकुलेट करते वक्त हम डेड लोड कितना लेंगे और लाइव लोड कितना लेंगे, राइट. So as you can see, dead load we are taking the 100% because of हम ऐसा assume करके चलते हैं कि सल्फेट जो है वो एज इट इज रहने वाला ही है, और assume करने की भी जरूरत नहीं है, ये इनफैक्ट है. while acting the earthquake forces on the building, सल्फेट उसका रहने वाला ही है. जो लाइव लोड है उसको हम पार्शियली लेंगे क्योंकि हम ऐसा assume कर रहे हैं कि हमने जो लाइव लोड से स्ट्रक्चर को डिजाइन किया है एट द टाइम ऑफ द अर्थक्वेक, मे बी 25% of live load will be there or 50% of the live load will be there, but not 100% of the live load will be there at the time of registering of the earthquake structure. So ये सब हम कैलकुलेट करेंगे. So while calculating the W dead load, we are taking the 100%. So डेड लोड जो है वो हम 100% कंसिडर करेंगे और जो लाइव लोड है उसको हम पार्शियली ही कंसिडर करेंगे. सो वंस अगेन दिस इज द फॉर्मूला VB इक्वल टू AH इंटू W और ये जो AH है वो हॉरिजॉन्टल एक्सेलरेशन कोएफिशिएंट है. So AH means horizontal acceleration coefficient. So this one is the AH, horizontal acceleration coefficient, and the value of the AH ranges from 0 to 100%, or you can say 0 to 1. So AH value will be vary between 0 to 1 or 0 to 100%. So VB equal to AH into W. So this is the formula. So first of all, we will calculate the AH. First of all, we will calculate the AH. Then after we will calculate the W, and we will multiply these two values, and we will get the VB. That is design base shear. So VB is nothing but the design base shear. So this design base shear we are going to calculate, and the value of design base shear it is divided into each and every floors. So मान लो कि आपने एक वैल्यू कैलकुलेट की और आपके जितने भी फ्लोर हैं वो सभी फ्लोर में ये वैल्यू को हम डिवाइड करेंगे. Okay, so this is how our first method, that is static analysis method, that we are going to be calculate. So in the next video, we are ready to calculate the AH value. Then after, we will also calculate the W value. We will multiply these two values. So we will get the VB, that is design base shear. And after getting the design base shear, हम जब हमें डिजाइन बेस शेयर मैन्युअली पता चल जाएगा तभी हम ये सब जो हमारा बिल्डिंग है उसमें जो भी प्रोविजंस है वो सब प्रोविजंस के अकॉर्डिंग सब वैल्यूज के अकॉर्डिंग हम स्टार्टरो में उसको मॉडलिंग करेंगे और हमारी जो मैनुअल कैलकुलेशन की जो वैल्यू है वो स्टार्टरो की कैलकुलेशन से वैल्यू से मैच होती है कि नहीं होती है उसको भी हम डिटेल में कैलकुलेशन करेंगे. So we will meet on the next video with starting of how to calculate AH. AH means design horizontal acceleration coefficient. Okay, so we will meet on the next video.